This is our AP Chemistry Lab, the chemistry of copper. The purpose of this investigation was to familiarize ourselves with the chemistry of copper, the types of reactions that copper will undergo, calculate a percent yield to achieve our overarching purpose of understanding the application and conservation of chemical reactions. The processes of this investigation included the preparation of copper 2 nitrate solution, preparation of copper hydroxide, preparation of copper oxide, the preparation of copper sulfate solution, and the regeneration of the copper metal. By subtracting the weight of our filter paper, we found out that the weight of the copper that we recovered was 0.27 grams. Dividing 0.27 grams by 0.45 grams of our original copper, it was revealed that we recovered 60% of our original copper. Our results based on the percent recovery equation was that we recovered 60% of the original copper. Our results were lower than other groups in our class when we compared them to each other, but this phenomenon can be explained. Since the series of reactions in this lab begin and end with copper metal, no copper is added or removed, so we should be able to quantitatively recover all the copper metal that we started with. However, we could have lost some of the copper during one of our reactions. For example, when our Buchler funnel tube was faulty, or when we left copper on the side of the ceramic at the top of the Buchler funnel instead of on our filter paper. Likewise, other groups could have also done similar errors. They could have recorded their copper before it was completely dry, thus adding some weight of the water, or not allow the reaction to go to completion. For example, they added too much H2SO4. I know that our data is valid and reliable because we compared with multiple other groups, not just the ones in our class. I compared with my friend Sanjana, who's in Ms. Renato's class. Sanjana's group got a 68% recovery, which is not too far off from our 60% recovery. To recap, we invested the transformations of copper through a series of investigations, and it's clear that it's possible for copper to be recovered through these transformations, as some groups, like Judy's group, got 100% recovery. But what we learned about this lab with our data was that because we only had 60% recovery, we need to be very, very careful in each of the steps. If we paid more attention to the setup of all the reactions, we could have recovered more copper. However, we're still doing okay because we got 60% recovery and not 0. Now on to the pre-lab and post-lab questions.
When the zinc undergoes a reaction with copper, hydrogen gas is also produced because there's no H2SO4 inside the solution, and therefore, either by the reaction of the Cu2+ ion or more likely the Cn2+ ion with the H2SO4, CnSO4 or CuSO4 is produced, the hydrogen gas. In the final reaction of this experiment, we use a large excess of zinc in order to ensure that all of the CuSO4 is reacted to allow the reaction to go to completion, therefore allowing all of the Cu as a solid to be recovered. Balanced reactions for the reactions in this experiment are here as shown. So as you can see, CuNO3 and 2NaOH form CuOH2 and 2NaNO3. Additionally, CuOH2 and then form CuO and then also H2O or water, and then the CuO and the H2SO4 form CuSO4 and H2O. And finally, the CuSO4 and the Cn form copper metal and zinc sulfate. So in order to classify these four reactions, here is the answer. First one is precipitation reaction, next one is decomposition, then double replacement, and finally displacement, or in some cases also called single replacement. So by going through all of the reactions shown here, you can find that the ratio of copper in the initial reaction to copper as the final product is 1:1. So therefore the same amount of copper is produced that is also used. And based on this, using stoichiometry in the final equation, we find that the number of moles of zinc is also equal to the number of moles of copper. So therefore, by taking the number of milligrams of zinc used, converting to grams, dividing by the molar mass of the copper being used, and multiplying by the molar mass of zinc, we see that by inputting 85 milligrams of copper, we get 87.5 milligrams of zinc.
oxidation half reaction is Al turns into 3Al plus 3 plus 6 electrons. The reduction half reaction is Cu plus 1 plus 2 electrons. Turns into Cu as a solid with a neutral charge. However, since it has 2 electrons, the reaction is a charge. Thus, you have to times that reduction reaction by 3 to get the reaction to be 3Cu plus 2 plus 6 electrons to get the 3Cu neutral charge solid. 1.5 moles carbon dioxide is also 66.02 grams of carbon dioxide, which is the amount of grams, the most amount of grams that we produce. If you had 8 grams of methane and you were also allowed to burn up to 6 grams of oxygen, you would only be able to make around 4.97 grams of methane, 0 grams of oxygen, the amount of milliliters of 6 molar sulfuric acid that are required to react for 0.8 grams of copper 2 oxide is 1.677 milliliters of 6.0 molar sulfuric acid. For the 2 grams of zinc that is allowed to react with 1.7 grams of 1.75 grams of copper sulfate, the amount of zinc that will remain for this reaction is 1.28 grams. The complete balance reaction for this question is copper sulfate plus CuSO4 plus CuSO4 plus Cu.
Thank you for watching!